Okay. Hey, everybody. Welcome to this session. Thanks for so many of you coming out and joining what I think should be an interesting discussion. I am going to start with just a little bit of a presentation here, mostly to set the stage. And you should now all see my screen. Yeah, cool. All right, thumbs up. So yeah, the point of today is, and for those of you who were on our demo day at the end of the year last year, will know we have been internally discussing what we're calling Web Native DB, right? Which is basically the next major piece of our platform that yeah, is currently, we're discussing internally, very much in the research and design phase. And we sort of teased it at the end of, or during demo day last year. And there was a ton of really positive feedback and people were excited, not only that it's coming, but that they would actually like to participate, have thoughts, input, etc. So we put together this session, which again, like I said, we're intending as more of a discussion as opposed to us, you know, unveiling anything, right? So it's early. We have had a lot of back and forth internally about how we think things should work, some of the goals that we have, things we'd like to have this system do. And basically this is our first opening up that discussion to a broader audience. So very high level. Yeah, so Web Native DB is going to be part of our Web Native SDK, right? So, you know, when you add the TypeScript library to your project, in addition to getting our authentication and access to the user's file system, you'll also have database-like functionality. And sort of the only thing that we're really committed to at this point is that Web Native database will be built on top of Web Native file system for its durable store. Basically, everything else is fair game. So yeah, so again, like I said, we've had some discussions internally with some of our design goals. So things that we want to make sure that Web Native DB adheres to as part of our broader sort of vision and goal for our platform. So some of those things, and again, these are some hypotheses or just like broad goals. People on this call may have other ideas, right? You may want to add to this list. Feel free to debate anything on this list, although given that I've now met almost everybody on this call, I don't imagine there'll be a lot of pushback to this list, but anyway, yeah. Some of those things are, so a big thing for a database is ultimately it should be multi-user, right? So being able to have data incoming from multiple users of your app, right? So right now, most of the apps on the Web Native platform are like built with Fission are single user apps, right? So this would be a way to be able to have multiple users adding data, whatever that looks like. So yeah, and part of that again is joining and leaving semantics, right? So you're able to add yourself into, you know, this collection of data and then remove yourself. Like all things Fission, it should be offline first, right? So what does that look like? How does a user update data when they're offline? What happens when they come online, syncing, all that kind of stuff. Again, like everything Fission, user-centric design, right? So the user ultimately has control over the data that they are adding into a database. Yeah, being able to reuse in multiple applications means basically like the data shouldn't be specifically tied to any one application. Again, ability to merge and aggregate from multiple users. And part of, I think one of the goals, again, broadly with Fission, but specifically with this is we've spent a lot of time so far internally discussing what's the API, right? Like what does it look like for developers to use this system? because underneath it's probably going to be fairly complex, particularly for new developers or strictly front-end developers, right? When you talk about distributed systems, right? But how can we basically put an API layer on top that feels either or comfortable and intuitive, right? So to a developer, we want to have the experience be as simple and straightforward as possible, and try to encapsulate as much of the complexity as we can. So to sort of frame the discussion here, we put together a quick list. Again, this is by no means extensive. We're looking to the members of this call to, add additional things, but for the sake of getting conversation started, right? We came up with a list of some of the things. So the thing, again, that I'm sort of most focused on or has been taking up a lot of my headspace is what is the preferred API, right? So developers on using web native, what makes the most sense for them to use web native database, right? So we put together a list of the kinds of things that we've tossed around, right? So something that's like SQL-esque, right? Like an SQL interface. For those of us who have been doing this a long time and have used relational database systems for a long time, that may be comfortable, right? I'm definitely guilty of that. That feels like a very comfortable, intuitive interface for me because I've been doing it for 25 years. For a lot of newer developers, that's probably not a comfortable one. GraphQL is another interesting one. It's very popular in a lot of circles today. Does that make sense for this kind of system, right? Is another sort of discussion point. What are the trade-offs between having something that is either familiar or popular currently versus like, does it actually make sense for the system that we're building, right? And then the others on the list. So something like an ORM, right? So like adding another layer, further encapsulating what's actually going on under the scene and talking more in terms of like models, right? So you have the objects in your system and those are the things you interact with. And as a developer, you're less concerned about what happens underneath, right? So moving on beyond that, schema validation versus anti-fragility, right? So there's a lot of, I think, personally, again, throwing a little bit of my bias in here, like I think there's a lot of value in having fully defined schemas for your data, right? So this is, I see at least a couple nods. Again, probably not alone in that, but yeah, being able to define the schema of your data, right? Particularly when you're talking about multi-user apps, you want to make sure that there's some predictability in terms of the data that you're getting. However, the flip side of that is, how should web native database handle poorly formed data, right? And I think a related thing too is that's in the right hand column is how do we handle changes to that schema, right? Like if your data model changes over time as your app evolves, right, which they all do, what's the story there in terms of making sure the old data and the new data can coexist? A couple others. I don't think we need to go through all these. Like I said, basically the plan for the next hour or so is to go around the room to start. And I'd love to hear a little bit about, those of you, you're presumably here because you're excited about Web Native DB. You're interested in talking about the design of it. So a little bit about, your concern. We have a bit of an expectation that there's sort of a divide between people who are interested in sort of consuming this API as a developer. And then there's some more sort of like protocol level geeks who are interested in how does this actually work under the hood, right? So, and there may be some people on the call that have opinions on both. So, we'll go sort of around the room and talk about So, brief introduction and sort of what your concern is, and then, or like your, what is your focus, right? Like, are you interested in the API level? Are you interested in the sort of the inner plumbing? And then, feel free to pick up any one of these topics, or if you've brought your own, discuss that. I'm going to take some notes, although we are recording this, so I'll probably mostly watch it after. But yeah, we'll let everybody sort of say their piece. Obviously, you can pass if you're not interested in speaking in the group or are just here to observe. And then I imagine from there we'll have some topics that we can sort of drill down a little deeper on. Sound good?
Yeah.
Any questions before we start going around? Cool. Okay. I just want to make sure that I can see all of your lovely faces so I don't miss anybody. So we'll start with, just in order of how you're appearing in my Zoom screen. Helder, do you want to introduce yourself and talk a little bit about what interests you with Web Native DB?
Yeah, sure. Hi, everyone. I'm Helder from Brazil. I'm working on Kickoff at the moment, which is a lot kind of like predictive programming, Forth-like thing. And yeah, I'm mostly interested in the Web Native DB from a user perspective, like to figure out what kinds of things I can rely on it and versus implement from other parts. To give an example, like at the moment, the way I'm implementing Kickoff is I use Git as an append-only log for event sourcing. So I have like empty commits that don't change any files, but that use the message content with serialized JSON to store like auto merge, patch data points. And so I'm using auto merge as for the CRDT capability because well, one good point about the Web Native DB is that like nowadays, like all apps are multi-user apps, even if it's just between you and yourself, because you're like multiple devices and they like the offline first idea. And so I'm using this initially just for syncing with myself, but to enable other users as well. And so I'm interested in this intersection between like event sourcing and conflict resolution and schema migration. Also following Ink and Switch, and they have this work on Cambrian, which I started reading. Haven't got very far yet, but like how to, because it's one of the like weak points of event sourcing, as people say, like to evolve schemas, and also thinking about how to create these shareable schemas as we want to have like multiple apps using the same data formats, and how to make it easy and effortless for people to share schemas that apps can reuse to have like different views and editors for the user's data. So this is rough drafts of what I come with in terms of my interest with Web Native DB.
Yeah, that's great. I mean, I think a lot of that aligns with some of the stuff. So yeah, when we talk about schemas, there's having well-formed data for your app, but then also potentially, right, if you're using a common schema format, I know like Stephen, for instance, is very interested in this, having common schemas that other apps could potentially pick up that data and do something else with. Very cool. I just want to ask a quick question. So in terms of API level design, what in your opinion makes sense as a developer, right? For how you would interact with Web Native DB? Putting you on the spot.
Well, yeah, well, honestly, I'd rather have this like Web Native DB be one of the backends that some other like higher level library uses to store things. So for example, I've been looking at XState, the state charts library that people are using with React, and like Redux, they have this idea of like it's based on event sourcing. Like you have a log of user actions, and from a user perspective and thinking of a user with a bit less experience, like it would be really nice if those things just work. Like, oh, I use Redux and I can just like plug this into Fission somehow, and my events get synchronized, and I don't have to interact directly with the API. So I haven't done much low-level work on this myself with like Kafka or some other like event sourcing solutions. So I don't know how the interface between these libraries and Web Native DB would work like. But one model I have in head that is very I don't know, representative to how I'm looking at this is just like Git. So the very basic of it, I imagine, would be something like Git plumbing commands, and then on top of that, higher level APIs that that's about it.
Cool. Yeah. Well, thanks for being guinea pig and going first. So next on my list, in no particular order, is Antoine. You want to introduce yourself and talk a little bit about your interest in Web Native DB?
Right. Do cut me if I take too long, because I have so much to think and to say about this. I've been thinking about developing a similar system. What I want is a protocol layer between systems. So for me, it's whether it's just many distributed web systems existing or centralized, but I'm interested in tools for collective intelligence, and that means tools for connecting the multiple views of data that different people have. And so my interest in what you're doing is you very much have a per person event stack. And that is close to how I'm seeing things. I have the way I'm thinking about this at this point, and I'm trying to write it on my own, but I would love to work with other people doing this. So that's, and I'm trying to see, is there a match at this point? Now, do we have the same goals? But I do very much see an event sourcing. So everybody has events, and everybody has, like the schemas are part of the view. Like if I see a certain schema for an entity, you may have a different schema, but we have the same events making micro assertion about the properties of entities. And they might materialize as one schema in my database and another schema in your database. But we can still refer to one another's entities and properties, which allows the interoperability and speaking about the same entities across systems. So I'm very much seeing a GraphQL consumption because people are familiar with that, or yeah, plugging it into Redux sounds great. But either it can be consumed as events, right? And then you're just basically saying, this is the view I want, so this is the view I'm creating. Or you can consume as types like GraphQL types, if that's the level you're interested in, if you're just looking at the state rather than the progression. But it means that if you have a per person schema, it means that the question of, for example, you were asking about whether we want to have schema validation, right? It could almost be individual, right? This validates in my schema and not in yours, because those are points of view in the way I see things. And what's very important for me at the next level, because I'm interested in collective intelligence tools, is how can we negotiate between the individual view and the collective view? So basically having events that combine, or socio-technical protocols that combine multiple persons' viewpoints into collective view and compare my individual view with the collective view. And that way, I do agree with what Helder was saying. My model, I mean, we're programmers. It is our model for a lot of us. So I'd like to be able to compare my branch of a certain entity to the community trunk.
Yes.
So that's the kind of, so there's how you consume it, which it can be very individual, but underneath what we have is basically microclaims about this entity has this property, and those are the event stream, and how those are combined in collective event stream in a quote unquote trunk, which of course has a fractal structure. So I have a lot more to say about all this. I've been thinking about it for years. And yeah, I'm curious to see if there is a match, but there's certainly many elements of match. So one last thing before I leave, you're aware of underlay?
Oh, sorry.
No, do look at underlay. It's one of
underlay.
It's one of the many groups thinking about things in those terms.
Yeah,
I will say, Marc-Antoine, that I have thrown a backlog item about whether we could actually have first-class backlinks, essentially as a building block. Right underneath, we've got IPLD, which is a graph structure, and we've got SIDs as unique identifiers. So theoretically, we could have that not as something that each app has to implement, but something at a much lower layer, which probably is the kind of thing that you're interested in, right?
IPLD is doing a graph only with immutable objects. And the whole point of a knowledge graph is that each knowledge item is incredibly mutable. But the attributes of each knowledge item are made from the immutable assertions, if you will. The assertions are immutable, they're the events, but they constitute this picture of what we know, all everybody has said about this knowledge item. And that is highly mutable, much more than even IPNS appropriate. So yeah, and I think your CIDs are close to what I see as the identity of knowledge item.
They're completely immutable, so not really, but that's an interesting point. Thank you.
Cool. Yeah. So just in terms of level of interest, it sounds like maybe all of it, but are you more interested in the consumption API or the inner working plumbing, sort of how it's built?
Definitely plumbing.
Plumbing, yeah. Okay. Cool. So next in my random grid of faces, although I'm skipping Fission people for now, would be Brian.
All right, hi.
Hello.
So I'm Brian. If you were at the last thing back in December, I make Moonforge, which is a web audio app that's currently using WNFS. And my interest is mostly at the API level and kind of as a consumer. I'm kind of like intellectually interested in the other stuff, but realistically, I'm going to be kind of like a user who's like working with this, and so the API stuff interests me. And the thing that I wanted to bring up or kind of like raise in the discussion is, I saw on the first slide this idea of like that the database would be multi-user, but also multi-application, and then we might have schemas.
Yeah.
So if it's multi-application, who designs the schema? You know, we're sort of going with this idea of like, no application is going to own the database, but somebody's got to design the schema. And I understand that in some, spaces we can have common schemas where it's like, okay, this is just like everybody knows that this is the schema for like this domain, and it's pretty easy to agree on. But for something like Moonforge, I mean, you know, it's like a total one-off, like, you know, the schema has nothing to do with any other app. Or, well, it could have something to do with other audio apps, but it's really custom. And so I don't know what the answer is, but I feel like there's, you know, some tension between like apps not owning the database and whether they are able to design the schema. So I don't know, maybe apps can design a schema, but by default, other apps can link into that if they want to use the schema. So I'll just throw that out there as something that I think could use more like exploration and definition. And going back to, yeah, go ahead. Oh, so
it was
yeah,
just a random cough. Yeah.
Okay, no problem.
No. No. It's not a random.
Okay, no problem. And then going back to like, how do developers interact with the API? I guess, or with WNDB, like you know, for front end developers, I don't think that they're going to be too familiar with SQL, and maybe they're not going to. Obviously, there's a huge variety, but there will be a lot of front end developers who learning SQL will be kind of like a barrier to them. I think ORMs are easier, or an ORM type interface would be easier for them to pick up on, even if they're not familiar with it. And GraphQL obviously has some advantages that a lot of front end developers are using it, you know, across, you know, certainly React, obviously, and Elm to a certain degree, Angular maybe a little less so. I wonder with ORMs if it's going to be kind of like, if ORMs are a little more like framework specific, and if that leads to like a lot of like different versions of ORMs versus like GraphQL being like a little more generic. But I guess I kind of lean a little more towards GraphQL and ORMs as being like the most broadly accessible, though I certainly would invite SQL as well. So
cool. So when you were talking about multi-apps and schemas, I saw a lot of head nodding and physical reaction. Anybody want to pop in with some thoughts? No?
Sorry, my video wasn't on, so that's why
okay.
it was. Yeah. Oh yes, Brian, I think you hit the nail. It's the you know, who owns the schema, who and all that. So I think that two things is this is the level where I'm most interested in. That's what Trailmax would be doing. But I just posted Graphql AI, which could be an inspiration, because that's a kind of way of describing in a very programmer-friendly ways schemas, which themselves can be kind of sort of change on the fly. So this is just for that. So I did want to comment on that. I think this is, but at the same time, I agree that there's this sort of standard ways and the known ways, and of course, to some extent, you got to cater for that. That's just not an option, because you know, even SQL, because there are a lot of people in here who've been programming for 25 years, and they would love that. So I think it's more like, in my view, a kind of, and hopefully it's actually the community can provide those APIs. That's the way I view. But anyhow, so I come back to it. But I'm very, very happy to hear what you just said. Thank you very much.
Oh yeah, good thoughts. Thank you.
Yeah, I think one of the interesting possibilities that we've tossed around is, with something that's event sourced, right? You could theoretically replay the events and apply new schema things, right? Which is very much, touches on what Marc Antoine was talking about, right? If you start to consider a schema as something that happens sort of after the fact, right? Sort of like on read versus on write, right? And then of course there's what are the semantics then around data that doesn't fit, right? So just silently get dropped or what happens? So all interesting stuff. Cool. Anything else, Brian?
Nope, that covers it for me.
Cool. Next in the random face grid is Antoine Herzog.
Hi, thank you for. So first of all, I joined like 5-10 minutes after the beginning, so maybe I missed some, slide, and I'm sorry about that. However, I can give some perspective of what we. So we are working on, human readable address, and I'm really interested in building some kind of decentralized application around the topic of exchange, like doing some kind of similar than local Bitcoin, for instance, where if you have a marketplace and you have offers and you have users who decide to eventually trade the Bitcoin against some cash in Venezuela or different countries where it's difficult to the bank system is very limited. So in order to do that, we would need so we want to make sure the user is owning the data, and so we would love to see how WNDB can fit into this picture. Regarding the API itself, we don't really care. I mean, whatever it's GraphQL or it's not. We can use whatever API you have. It's more, I think, in the feature itself of the database, where actually that's something very important. It's first, yeah, for sure, the user needs to own the data. Two, being able to query, for in our case, like all the list of offers and everything. I think that usually database, you have some kind of security around like who can do what and who can see what. And this is where actually the problem is very difficult to solve, probably because most of the third party hide everything. So you can have very specific access of, they can give you a view which is very specific to your right. As soon as the data is probably distributed, then it comes more for cryptography, but maybe zero knowledge proof. And this is where actually it's not easy. And the last thing that I would like to say around schema, and I think that's a very interesting topic. I think that we should be able, as the developer of the application, to do whatever schema we want. However, what is really cool, if you can really see which schema are really popular and for which kind of needs. And so instead of doing your own schema, you could like fork or use one. And so you can build more like popularity around some use case with some schemas that has been already done. And this, I think, is really powerful. It looks like a little bit like you want to use a library in NPM, you see which is the most popular one, and you start from there. And we could do the same for a schema. That's most likely what I wanted to say. And I'm a big fan of WNFS and looking forward to see.
Good. I'm waiting for Boris to announce the schema marketplace.
I just wrote it down.
I knew it. I could feel it.
I think it's a really good idea. So I think there's all these different semantics, and they go all the way down. So Antoine, you as someone who's creating an app, which is a marketplace, the OMO team is also doing marketplace stuff, but an inverted marketplace where the users own their data. And then as the marketplace curator, you want to do aggregate views. So we've had aggregate views on our list for a while, which is the default case of everyone else because it's not owned by the user. So this is one of those cases where some of the use patterns ideally match all the way around, right? So you've got apps and you've got code. That app operates on data. You've got users of that app and you've got developers of that app. So ideally, what we will all have together is some rich building blocks that we can reuse. So we're very inspired by Heroku. And Heroku is pretty low level. I would say a design goal that maybe wasn't stated up front, and we're both at API and protocol design here, is that we want this to be batteries included. what's more batteries included than not even having to design your schema from scratch? Right? So, and something like a schema marketplace, whatever that is, goes like, oh, here's a notes app that includes versioning, and I could just start with this and then add, you know, an attribute or something like that, right? To turn a notes app into a cheese logging app where you have the region where the cheese comes from, or something like that.
Pairs well with pretzel facts. Yeah.
Yes.
And I think that in this setup, the developer will have always a trade-off, but that's his choice. I pick a schema which is super popular, so I will leverage the user base from this popular schema, or I want to fork and then I start from zero again, where actually I will need again to build the popularity and you know, the user base. But most likely for marketplace, like people who like to go where you have the most users. Whatever, like, you know, and this is, and they don't care. And if you look at like very successful marketplace, it's just because the number of users, everyone is there, so people go. And so I think that that's super good if there is no anymore software party, just user data, and then user know exactly where like the entry point to, you know, to access all the offers or whatever.
Cool. Okay, Boris is next in my face thing, but I'm going to skip you for now. David, you're up next.
All right. Hey, I'm David. For the past 8 years, I've been working on a project called Feathers.js, which is like a library to let you build real-time apps and web APIs. I'm interested in like just WNFS in general because Feathers is transport agnostic. So right now you can create APIs with HTTP or WebSockets, but you can just replace that and still build things the same way. The database is interesting because it supports a lot of different databases, and we had like a higher level abstraction layer where you can like have a top level API where you can access different databases the same way. So there's a couple of lessons learned there. And for the past year and a bit, I've been also working on doing adding JavaScript schema definitions and resolvers and validators to it. So it seems like there's a lot of overlap there. And I'd be happy to share any of the lessons learned in the past 8 years about some of those things. I'm not going to go too much into it, but I have some reservations about GraphQL that I think can be done better. And, you know, if we're already breaking the web as it is right now, we might as well go all the way out. And yeah, really interested to see where this all goes. Yeah.
So aside from without going through all 8 years, and yeah, aside from GraphQL reservations, which again, judging based on nods and smiles, you're probably not alone. Like, what other sort of are there some like quick lessons learned that you could share with your experience?
So one, the database abstraction, just having like a high level, like basic query that covers like basic query parameters and things like that cover 90% of the use cases are quite doable. So the things that are offered by the Feathers official databases, you can connect it to any database, but there's some official adapters that you just plop in and you get like CRUD functionality. You can query for things. That was surprisingly solid. Like, you know, there always is cases like, oh, I need to query for a name. I need to search for greater than a certain number and all those things. So that was held up really well as long as you make it extensible and allow to add your custom functionality. But it covers so many use cases that for a lot of people were just happy with just having that work. which is really interesting. And I think there's something there to share, especially something a lot of people are already familiar with, because it's also similar to like MongoDB. And then to the schema part is that it's hard, but I would love to have that. So where Feather started was like abstracting the API, so that you don't have to worry about, do I use HTTP or do I use REST? Do I use WebSockets? Do I use GraphQL? It just said like, oh, this is my high level API. I just call it, and the framework, because that's the job, in my opinion, of a framework, is figuring out how to do the connection between clients for you. So I'm hoping like to have something similar for schema definitions, where you define it at a high level, and then the framework just figures out, okay, I gotta create SQL tables based on this. I gotta create a JSON schema or a GraphQL schema based on this. But you have this high level JavaScript definition that, you know, every web developer knows JavaScript. So I would like to see something like that works across like many different platforms, because then that even abstracts away GraphQL if you include things like how do I resolve dependencies and all of those things. So I'd really love to see some kind of high level JavaScript schema definition and validation and resolver API that can be used for all kinds of different systems.
Yeah. Cool. Have you explored some of the existing, well, of course, all I'm going to be able to pull off the top of my head is JSON schemas. But like, have you looked at some of the other schema defining efforts that are out there in terms of where they fit? Yeah.
Yeah. So JSON schema was interesting just because it's pretty sturdy. The problem is you can add dynamic things like resolvers, right? So you have to do that with references, which is kind of weird, because if you have a JavaScript app, you can just tell it like, in this function, just return the dependencies that you need, which is what GraphQL JS does, and which I think it does well. It's just things that are not done well. But that part is really, really good to, in your schema, define on how you can resolve dependencies, and also having things like types built in, right? Because we need that somehow. I always said like, well, we have a type system in JavaScript already. It's called TypeScript, but there's still, I got it working a little bit to combine those two things, but it turned out that JSON schema is like the more flexible high-level abstraction, just because it works literally everywhere.
Yeah. Cool. Great. So I'm trying to watch the chat as well. Yuri, you're next up in my list, but you wanted to type only?
No, sorry, I'm here. Yeah.
Okay.
Okay. Want to be brief. First of all, I've got to say that Marc, Antoine, and me, and Jack, going back 3 years, we were working together on the mother of all demo 50th anniversary stuff. So we are all into augmenting human intellect kind of things. So that just explains the going meta level. But and I just want to say I spent a week after the demo, well, before Christmas came, and I haven't done anything for 2 weeks. Playing with web native, and it's amazing, because if you think about it, the folder is really the equivalent of the textile collection, except that it can contain, doesn't have to be homogeneous, and at the same time I put in an about HTML, write everything in HTML, and then you can actually define the schema for that. So there's a real mapping from MindGraph, my way of going meta, into the folder of the world. So it's actually got all the primitives you need as it is. That magic of you fiddling with the CID for the folder when it changes, that kind of stuff is actually, you know, it lays it out perfectly. So kudos. I mean, it's just amazing.
Thank you.
So, and there is that, I'm gonna dig it out, this IPLD, they got some amazing stuff. They do everything you can ever imagine you want to do with schemas. So please check that out if you haven't seen that. It's obviously not surprising because in a way that's what you're doing already. So and just trying to so that's the schema. I fully appreciate the need for supporting sort of the database idea, but actually, if you think about IPFS and the web native drive itself, and the whole thing is actually renders it obsolete. So, but you don't need to shout high about it. But the very idea of the database came from the
Well,
place.
yes, we're done here. Good call, James.
Yeah. Our work here is finished. It's all done.
No. I mean, certainly the event, as Mark, I agree with Mark, the event model, is really critical because I think James, you did say that actually with the event you can go meta. So you definitely, I'm looking for some way of doing that. And the other thing which I've been exploring, and I certainly would like to see it it actually seems to me that you can actually have a global giant graph. So in a way, as soon as you add the multi-user, and as soon as you add the facility to communicate peer-to-peer or within communities, user-centered in that community center, then you can actually have a global giant web native drive, which is actually web native from the user's point of view. You only see the bit that you actually explore, but it should be possible to reference real entities which can also co-evolve very much in the way Mark Antoine talked about. Just one more thing. I got too many things. Yeah. Okay, I think I stop for the moment, but I mean it's just amazing. So I think it's the event bus or whatever it is that I'm most interested in. And I also just want to plug once more. I think I looked at this Graphql AI. Did have some really neat ways of programmer friendly talking about really abstract things. So I recommend that, and thank you very much. Yeah.
Cool. Thank you. Samuel, you're up next. Just listening and learning today. Okay, so last on the list that's non-Fission would be Daniel.
Hi, yeah. I think I have some ideas and points which were not already mentioned. I'm coming more from an application developer perspective, so to say, but I'm also interested in architectural stuff that lies under all of that. And I also really like, for instance, linked data, RDF and all and stuff like that. So I really like the idea to have a really huge distributed database. But from a developer perspective, I have to say that I would prefer a very simplistic API where I could build my own abstractions on top of it. So what wasn't mentioned yet are, for instance, indexes. So I think a key value store with additional indexes would be really nice to have. And then everybody can build anything else on top with libraries. So for instance, I built some applications using SecureIS, and basically you can do it with every database. It's just an abstraction on top of it. If you have the really basic things like a key value store and indexes. So maybe the schema wouldn't be really part of the database then, but what one could do is the objects could be wrapped in some kind of envelope, and that envelope links then to the schemas, and you could have an abstract concept of collections which then are just WNFS directories or something. And the collections might have constraints on it, which can filter for properties or whatnot. So this would be my input from that side.
Very cool. Yeah, one of the things that I've been sort of chewing on is doing schemas at a model layer, right? So if you're defining models, have that be what defines schemas, and you can start to do like dynamic things in terms of resolvers and things like that at that layer, and keeping it again like a little higher level in your application as opposed to you know, something core to how the you know, like a protocol layer would work. Cool. Anything else?
No, I think that was it from my side. Thank you.
Cool. Thanks for sharing. So everybody else on the list is Fission internal. Anybody have things they're dying to share and talk about? Not calling out Brooke, but calling out Brooke.
I should go last because I'll just start talking until the end of the session.
Okay, so before we give Brooke the floor, Daniel, Stephen, I know you have thoughts on schemas. No, everybody's going to just defer to Brooke.
Oh, just
yeah.
Yeah, just I just put that tweet in because that was today. I found this is really interesting that it really points to one thing, which is the search. I mean, there should be a search across the web native file system as such. So so that's the one missing piece. Well, apart from all those that we already talked about, I think it's
right.
And I'm interested in what you think about that. But yeah, so I did want to say that's important. And
yeah, I think we're talking about a lot of different layers, right? When I said yes. Batteries included, so maybe I'll just speak to that briefly, right? So Fission's goal is all the way up here of having a platform that has apps and users and identity and data and encryption. As app developers, we can choose to put capabilities at a number of different layers, including something that I call platform superpowers. So some of those things can be implemented literally at the platform layer kind of by us and run as a whole in one way or another if it can't be run you know, fully peer-to-peer. So that's just something that we can do and take responsibility for as part of just making sure there's a cohesive experience. Underneath, we're starting to use some language around building blocks. So we try and use standards and open protocols, and generally have these building blocks that we build on top of, some of which that we inherit from things like the W3C, like our uses of the Web Crypto API as sort of a key building block. I mean, for that matter, a lot of our default stuff wraps like local storage so that you don't have to worry about whether stuff is cached locally, written in WNFS, for real, online and cached everywhere, and so on. So search is one of those things. And actually, you know, Daniel bringing up key value store is a really interesting piece. He's asking for, hey, can you make sure that in web native I get access to something as simple as a key value store that I can then use as a lower level piece to build on top of. Search is one of those really interesting things that we could do stuff at the platform layer as one level. And the other layer, so I have a bookmark thing, there's a search built in WebAssembly called Stork. I'll post a link to it in a bit. That's one of my backlog items. And it looks like a super capable search that fits our sort of bias towards WebAssembly, where just documenting that Stork exists and how you would use it would solve the problem. But there's a whole bunch of other things where, oh my God, could you search across all of the apps and users in the entire system? So wanted to give some color that like we're happy to talk on all of those layers, and we want to be driven by what consistently comes up. If every single app wants search, then if web native has a default API helper, which underneath might use Stork, right? And it's a balance for us of, we have some really capable, interested people like you all who are super capable of creating protocols from scratch. And then we've got a vast long tail of React developers who are like, I don't fucking care. Just give me webnative.search and I will use it.
Yeah, I think one of the most interesting things for me in this process has been how much of the we don't care, just tell us how to use it and we'll do it. That's been I may be pickier than most or something. I don't know. That's been an eye-opening bit of this process for me, is that yeah, most people are like, these are the things I want it to do. I don't care how it does them. Just tell me how to do these things with your platform. So it's gonna make my job easier.
It's still funny how everybody then has opinions about how it should be different when it is.
Yeah,
I had some like point about the search. I think it's still the same with if you want to do global querying as well, because I believe if every user has their own database and there is more data somewhere else, you still want to have that ability. I'm assuming that would be at the platform level too, right? Where you say like, I want all messages sent before July 1st. You can't necessarily query that locally either. So I think that's already a similar problem as search, right? If I understood that right, Boris.
Yeah. Again, there's a bunch of things where rather than making people jump through hoops, there's things that just end up being easier for us to do at the platform layer, right? And we have no hesitation of doing convenience functions at that layer. You know, Brooke just let me know that, like, apparently, unless IPFS or IPLD has solved this or is working on solving it, we're gonna have to come up with our own file size calculation because it's not built in. And I'm like, what? No one's done this yet. So that's another example of a building block where I'm like, someone else in the protocol maybe also needs this and can work on this with us.
Yeah. Cool. Okay, so maybe real quickly before I hand over the floor to Brooke, who undoubtedly has lots to say. Yeah, so sort of our assumption coming into this was that we'd have a little bit of both. Some people who are very interested in sort of protocol layer, how is this, you know, how does the plumbing work and what's capable, and then some people who, you know, we have quite a few of on this call who are developers looking to use the platform. And so so our intention, because this first sort of kickoff meeting was a mishmash of everybody, you know, it's intended as just that, a kickoff, and we're planning to do follow-up events that are probably a little more focused, detailed things. Again, certainly as we go down this road, you know, we'll want to share progress early and often with the people on this call, and hopefully more who we pick up along the way. So yeah, so probably everybody on this call, but certainly for anybody who's watching video and catching up, you know, the talk.fission.codes, which is our discourse instance, is where, you know, all announcements about follow-up events, right? So like subsequent meetings, as well as, you know, progress reports and other announcements will happen there. And I don't think we had anybody that really didn't get a say this time, but if you have further thoughts or want more time, the Calendly link there is a great way to book one-on-one time with members of the team, and we can talk, you know, either in further, you know, in greater depth, or if there's things that sort of occur to you after that you'd like to share. So with that, that's all that I had for this. Yeah, thanks everybody for showing up. And then I keep teasing Brooke that you're going to talk and share some of the thinking that you've done behind this as sort of the, you know, the chief architect here.
Okay, awesome. Yeah. Thanks, James, and thanks everyone for showing up. You know, this is more people than I expected to be interested in database plumbing stuff, so that's kind of great. Yeah, it kind of like, as James just said, it's this sort of like general first call about, you know, how, you know, people want to sort of, you know, bits throughout the entire stack. And that's kind of like, I think that's exactly what happened, right? You know, we have lots of people with interest in deep plumbing and other people who have more interest in the API and features, though I'm actually surprised that there wasn't more opinion on the exact shape of the API. But even then, you know, we know we need to do a lot of user research on that anyway. So I'm going to be talking more about plumbing. James is more API, and I'm handling the, you know, the underlying stuff more. So I definitely heard a lot in this, you know, event sourcing, auto merge, that kind of thing. So the constraints on the system really, because it's, you know, users own their own data, and maybe coming online and offline, needs to be multi-user, right? That starts to become a very good fit for event sourcing, CRDTs, that kind of thing, right? And so that's actually where we started. I had a hypothesis on, like, you know, doing a distributed database from, you know, 2-3 years, basically. That was very much informed by doing event sourcing in a centralized context. And then as I started picking up more distributed system stuff, started moving more towards something like auto merge. Problem with auto merge is it doesn't perform very well at all. And part of the main problem for that, and we've talking to some of the folks at Ink and Switch about this, and we probably will be using, you know, bits of things like Cambria, but the overall model in auto merge is really concerned and focused on the JSON document format itself. There's two big problems for us. One is it assumes that everybody can see all the data, which we probably can't. And if you've been offline for a long time, or you need to make a change, you have to have the entire log in order to make a change, and then pop back and replay all of your events, which can take a long time. So you'll open up an old pushpin document and it'll take 40 seconds to load because you're pulling in the changes and reapplying them, right? And the overhead is, even on their new performance branch, is extremely high. So on small documents, it's about 200x, and on large documents, about 43x. It seems to trend down to about 43x, not percent, x times the size of the document. So it gets very, very large. So that makes it not much of a fit. So talking with a few people and having some of these ideas, and anybody who's been following in the chat, I've, you know, been hinting at some of this stuff as well. Where I ended up with my current thinking is, so CRDTs come in two varieties, 3 really, but they work in fundamentally 2 ways, right? The state-based, which is what auto merge has, where you can do reconciliation on a timeline. And essentially what you're doing is you're taking a partial order, putting new things in the partial order, and then linearizing it and playing over those events again, more or less, right? And that's where this performance impact is coming from. The fact that we're looking at this as JSON in the case of auto merge, and this replay, right? Even if we might not care about some of this older data. And we're still really treating it in a traditional database sense, right? We have this document. The nice thing is it's in JSON, which is very familiar to front-end devs. And in fact, that's ideal, right? Because it's just dynamic JSON that's changing, right? There's some stuff about how they've implemented the API that maybe, you know, React developers wouldn't like as much, but, you know, that is a nice part. There's questions about different people needing different things out of schemas. Do we even want to share data across applications? You basically can't share data across applications unless they're consuming the same data, right? So maybe loosen that constraint, you know, not sure. But anyway, so that's the state-based. The other is operation-based, which is not operation-based in the way that, you know, there's even a paper making operation-based CRDTs actually operational-based, which adds to that. So instead of things just being commutative, where you can add things in different order and then they'll end up in the right sequence, they're also associative, which says you can put together and tear apart any set of these, and it's actually fine. So if we do, you know, A, B, and then C, we can do A and then B and C, right? So like we can do this plus the commutativity. So it ends up being this really nice, just set-based operation, right? Which is where Datomic started becoming more interesting. So for those less familiar, Datomic is from the people who created Clojure. It's schemaless underneath. So everything is represented as an entity ID, an attribute, a value of that attribute, and the transaction. Absolutely everything. So you'd say, here's entity one, its attribute username is, or user first name is Brooke, user last name is Zelenka, right? And then you can just start accruing data about each of these entities and relating them on this entity ID. The downside is it's schemaless, but on the upside, you can have two separate databases, merge them together, and that's fine. You can have part of the data be hidden and merge it in, that's fine. The one constraint you have to weaken in this is time. So you need to have a concept of not just ordering, you still need that because two things can't happen necessarily at the same time, right? Even if they have the same timestamp. So you still need, you know, a logical clock of some kind, but also you need literally when this fact will be true. So you need to have some temporal logic. So, you know, the canonical example that they like to give, which is interesting given the events of yesterday, is the President of the United States at 2016 is Donald Trump, and at 2020, I guess 2017 is Donald Trump, and 2021 is Joe Biden, right? And we can start making claims about the future as well, and those are as true. They just haven't happened yet, and we haven't, the view portion that we're querying is from this line, even though we know stuff in the future, right? The other nice thing about being able to pull apart data is this makes it more Byzantine fault tolerant. You can say, I've merged this in and I've made changes, but I need to pull this data out now because that's actually a bad actor, right? So there are some advantages to doing this. We get to share portions of data. So if you care about, you know, this set and somebody cares about this set, but there's some overlap, you can still share that overlap. And you can start doing like really nice global aggregation of data and gossiping data as well, which is not the main use case for this, but would be really nice to have as, for example, a Twitter feed, right? You could then gossip the information across the network in this way and say, well, I'm only going to take the bits that I trust because it's no longer depending on the structure. It's only the data. It's not rows and columns. It's not a JSON document with certain fields and nesting. It's just, here's a bunch of facts, right? So there's some interest in this direction. I wasn't aware of, yeah, Datomic Scuttlebutt. Yeah, basically, yes, yeah. I wasn't aware of underlay, so I'm definitely gonna look at that. There's a lot of stuff with RDF around this, obviously. The question, and this seems to be a viable direction forward. The main guy behind AutoMerge gave a talk 2 years ago or something like that, basically saying, like, because I was, you know, looking like, has anybody done this? And he has this talk saying like, this is maybe an interesting path that he just hasn't explored. The downside there is this is essentially unexplored territory unless underlay and some of these other links that have come up in this call turn out to have some work in this direction, which would be amazing. Yeah, the question becomes, well, what do you use as that top interface? So Datomic and DataScript, which is so Datomic is proprietary, DataScript is the JavaScript very close open source clone in JS. And that is used by, like Rome Research, which is, the new hotness right now. They're using that, but they use a query language called Datalog, which is in some ways simpler, easier, and more powerful than SQL. But do we really want front-end devs learning Datalog to use the database? That would make me very happy, but I don't think that's the goal here, right? So I more have questions around like, well, but then what are the interfaces we need to support, right? Do they need very structured data? Do they want, actually with DataScript or this model, indexes become very simple because it's just which item you put first is now your index in the 4 columns. We would probably need a 5th one, but in these columns. So you get indexes very, very easily, which is nice.
Mark Antoine, did you have a comment?
Yes. I'm saying I don't think Underlay solved the problem you mentioned, but the problem they did solve is very much take those data log items and make them into a schema, like present them as a schema. Say this is my schema, and this is how I want it to show. And that part is solved by Underlay. So I don't know if that's what you want. And I'm 100% behind everything you're saying, but of course, one of the downsides is when you need an ordered list, but that's thankfully rare. And often you can do it just by expressing order dependencies. So that's fine. So
yeah. So in this, so because we would need to add time to make this work, and start making assertions that include time.
2 times.
2 times, yeah. We need logical time and clock and wall clock time, right?
The time of the assertion and the time the assertion is about.
Yes, exactly, yeah. So there's, you can order by time if you accept the claim of here's the either, as you just said, the assertion, or when it was where in the global order it lives, right?
Distinct. You can have a recent assertion about something far in the past or future.
Yeah. No, that's what I mean. But you might have concurrent assertions because how data is going to travel through the network.
Later.
Okay. Yeah, so this starts to become, my concerns then start to end up more in the, well, how are people going to actually consume this? One of the nice things is you can lay this out as a table, as a graph, right? Like depending on how you do the ordering of these indexes, it starts to look like different kinds of databases, which is kind of nice, right? But what are people actually looking for, right? There's definitely people that are interested in GraphQL, and that might be a nice fit for laying it out as a graph. Some people want it more as tables, some people want models. From the few purely front-end devs, i.e. people who do not have a back-end background and have not touched SQL, the main answer I get is, I just consume whatever comes off the API. I'm like, but you're going to be designing the API. So bigger questions around, well, what does the high-level interface look like? Can this support that? My theory is yes. Can we make the plumbing? I'm fairly confident can describe data, be efficient, work in distributed fashion, et cetera, and that we probably can pull in existing work like DataScript to at least, on underlying layers. What does the top level interface look like? How is that going to be consumed by a React developer versus a Angular developer, right? What are the actual needs? How do people want to query stuff? I have, my own experience, but I'm also this like very weird dev who does things in a very weird way because I have all of, cursive knowledge and experience, right? That's skews very back-end these days, right? What does a front-end dev want in 2021? I actually don't know anymore. I've completely lost touch. So,
and I think what we're saying is there's this. So we use this terminology of front end dev, and we're saying, hey, plug in Fission and you don't have to become a full stack dev, right? So we're not making a biased discussion about how front end or back end is better or anything like that, but like your end goal is you want to build an app and we want to give you all of the pieces. So I think one of the explorations that we've had in walking through some people of wrapping their head around how this even works, especially who don't have any sort of Web3 or distributed systems background, it took them a while to believe that this was even possible. So one of the techniques we'd use that I'd love feedback on is we walk people through and said, okay, so you're working on the front end app and you haven't built the back end, you don't have anything connected. What would you do? And they're like, well, I'd mock some data in some JSON files. And we're like, great. With Fission, with Web Native, you would just ship your mocks. And then they just kind of went. So that's as far as we've gotten in exploring that, where the biggest leap or challenge has been is saying that this is even possible. David's made a very good point where it's like, who the fuck cares exactly how it works or how familiar it is as long as it actually works. So I think there's something there about very quickly getting to people something that is working. I think this schema stuff ends up being interesting. If you're staring at a blank schema where you're stuck even at like, I don't know how to mock data. James has been thinking a little bit about things like generators, right? Yep. So that could just be a thing that says, oh, like here's a little starter schema. And that can be part of the interface.
Well, and the schema marketplace idea that came up, right? Where yes, you, as the app developer, you always have control over defining your data, but for some apps, that's the hard part, right? And so maybe you can leverage, at least to start with an existing one. Yeah, I think so. Again, like we're very early in this process, but one of the most interesting early bits of feedback for me has been this like recurring theme, like I don't really care what the API looks like. As long as it does what I want it to do and it's clear how to use it, that's what people seem to care about. Which, for me then means, or leads me to believe like this is, our task is obviously designing the system to work and fulfill all our goals, but then it's really about, documentation, examples, education, like here's how to use this effectively, not don't worry, it looks just like Firebase, right? Because even those who have used Firebase, it's again, early feedback, but it's a polarizing topic, right? So, there's plenty of people who have used Firebase who, and I'm saying Firebase, any of the popular sort of platforms, this seems to be true for, they, tying yourself to that, that pattern, right, is actually like they may have had a negative experience with Firebase, and then they're writing you off because, oh, well, you're just like Firebase, so I hated Firebase. I don't use Fission either.
I think.
Yeah. I don't know who that was.
Sorry, just to briefly elaborate on that. I think that's exactly the point. If you say like, oh, this is just like that, everybody's like, well, okay, I don't care then because I didn't care about that before. That's been like, I've ran into that a lot. But if you say like, this is why we're doing what we're doing, and this is why the API looks this way. I wrote a long article on like, these are the design patterns behind all the stuff that I've been doing. And that's been going over really well because all of a sudden people are like, oh, I can even apply it even if I don't use your stupid framework, which is great because that's what we ultimately want, right? But then also being like, oh yeah, okay, now this actually makes more sense. And then there's much more willingness to use the API. And the API with Firebase is like, it's more like, oh, I'm paying for it, so I have to use it. Yeah. And that's it. And it works because I'm paying for it, right? There isn't really like, this is the advantages that you have by using it. It's just like, you have to use it because you pay for it.
Right, yeah.
I think Brooke's point about like, like you as a front-end developer are going to be designing an API for your app is kind of an important one. It's like, you might not care about the API right now because you're not a back-end developer, but you're going to be doing data modeling and you're going to be thinking about how this works in your app now. And so maybe like an interesting consideration is like, of that list that was on the slide, what makes it easier for a front-end developer to learn API design? Like how can they learn API design?
Yeah, I think data modeling is the better phrase there.
Yeah.
I think that's a really great one. And then that probably leads me to migrations as a word that might be used from elsewhere. Can I just make this change on something that 10 people are already using? Or am I going to have to write something so that it keeps working?
Yeah, I keep coming back to a very similar place where it's like, if we give you a way to define your objects, right? So some sort of ORM style interface, one I've been looking at, because one that, while, again, caveats, early small sample size, but, less Firebase, but a lot of experience with Mongoose, right? For this sort of like front end style, right? So and in Mongoose, right, you define your document structure, right, and then all of your interface to the underlying Mongo database is through your model queries, right? So, and I think and another advantage of again, so like as Brooke and I are talking, right, another advantage of going like that high level with something like that is we can do all kinds of stuff underneath, right? That just bubbles up into this ultimate interface that app developers are using, while also being concerned with some of the other stuff that's coming here. Is like, I think people on this call, maybe more so than some of our ultimate audience, would like basically to hop in the middle somewhere, right? So give me some underlying access to to some of the more like raw bits that are happening, whether that's data log or something else. Yeah.
Brooke, I wanted to make sure that because I know you've got lots more. I did want to say actually some scoping that may not be obvious for everyone. So when I'll say it, and maybe James and Brooke, you can correct me if I'm wrong. So right now, WNFS is implemented in TypeScript. All the web native SDK is. The plan is for all of this to be written in TypeScript so it can run in the browser. Make it work first. We definitely look a lot at WebAssembly, and there's things that we could do where if we have performance issues or security issues, because there's some things that WebAssembly could do in there as well, we could put in chunks of WebAssembly. I think our sort of internal take is that we'll probably head in the direction of Rust plus WebAssembly if we do anything in that direction. So just to state out loud where that's looking like. This all is open source and available. We have platform concerns. All of our platform is open source, so you can run the whole thing, but a lot of this will just like work together nicely. Brian, I think, is one of the people on the call who, as an example, hosts his web native powered app on, I think it's actually on S3, isn't it, Brian,
Yeah.
on Amazon?
Yeah, that's right, because it still uses, Moonforge still uses SPA routing, and so it's on S3, but uses WinFS, yeah.
Yeah, but uses a web native. So just to showcase, obviously this can kind of be used everywhere. And this is our building block approach where we're going to tune it and integrate it. And our assumption is that we're going to have to write the majority of this like ourselves, and are willing to do that. But we're also totally willing to do it out in the open and invite everyone to come along, whether that's I'd like it to work like this, or I have some cycles and I prototype feature X or whatever. So just to say that that's roughly what it looks like. Brooke? I don't know where we held off there from our really great discussion that we ended up in there, or where you wanted to keep going.
I mean that was the main stuff. I mean, like we can start getting into minutia, right? But like that, those are my main thoughts. Kind of where my head is right now on the plumbing portions, right? I guess the only other thing to mention is, so Cambria, super fantastic idea. Dynamic migrations, essentially, it seems like a win. And also the ability then to translate between, even in an event source system, which is, I think, why they needed it, right? To upgrade as you're going, or even take newer stuff and put it into an older store, right? So handling migrations with just these, these newer techniques that don't actually even necessarily require touching the database seems like a good idea with very little to lose, other than if you have lots of data, you might want that to happen and actually persist that, right? But being able to do that dynamically seems like a good idea as well. So that's sort of like database, yeah, it's still like database adjacent or really in there. And like, well, I need to add a new field to my schema. How do I do that? Well, here's an easy way to write a lens, but like, we can have nice helpers for that. Or, here's how to go to and from, and here's the version numbers, and there you go. Yeah, that was really the only last thing that I had on my list here. Middleware, since that's come up a few times. Something that we've done really from the beginning, though it's been interesting that nobody has used this really, is building blocks and saying, cool, you only want this bottom layer, go for it, it's yours. This layer on top, well, it depends on the things below, but you can just use this section or this bit, right? And so we're trying to keep things fairly decomposed. Nobody seems to really use the individual pieces, which I guess is not that surprising because people want convenience and a complete system, right? But because we're going to have this front end back end distinction on the database design, right? There's nothing stopping somebody from going into the middle and being like, well, I want the interface to look like this instead. So yeah, absolutely. Yeah.
Something else, and I don't know how much of this we're going to write down. Brooke has written a ton internally around this, and some of the stuff we just have to kind of put in a way that it's consumable. But some of it is really like step one, read these 18 papers and go talk to the author of AutoMerge, which is some of the stuff that's been done. Something that came up, and I mean, we've been looking at it for a really long time, is, and a question that comes up is, why not OrbitDB? So Brooke, maybe you can
I was actually anticipating that happening and it didn't. So
yeah. So Brooke, can you maybe briefly touch on that?
Sure. Yeah. I mean, we've talked with them a while ago. The short version is, so OrbitDB provides you just a series of CRDTs with very little extra structure in them. The log, when I was looking at, well, we're going to do something like hypermerge, but instead of on DAT, we would do it on IPFS. It's like, well, yeah, the OrbitDB log totally makes sense. Does any of the rest of the stuff make sense for us? Not really, right? So it's, they were funded. They've gone back to being a community project. I think it's a great project for them to continue pursuing, but it's just really not in the right place yet. We've seen issues with corrupted data, logs that are getting too long, and because it's using a lot of state-based CRDTs, will run into the same performance issues in the long run as AutoMerge. But there's bits that we can maybe pull out of there, though I don't think we're going to be using a state-based system.
And I think probably another piece, so because there's lots of other things happening in IPFS land, and people have looked at us kind of funny of like, you invented what now? Is that we went all the way to including private files and encryption. Lots of things that are public only end up being a lot easier to handle. And that's the other piece that we've just sort of, solved from a building block perspective. And so we'll reuse that.
Can I come in on the OrbitDB thing? I think if you combine OrbitDB with the web native file system, you can get something really amazing. I think that's what I'm thinking about.
So yeah, that's the challenge. I mean, you could totally use it, and you can like publish the actual files to Fission.
That's it. Fission adds me the encryption.
So,
So
we're
that's one of the-
specifically saying it has not proven to be a useful building block for what we need to do.
Yes,
and I think that's the other thing as well.
I'm not disputing that. What I'm saying that if you have Fission, everything that it is with it, and you actually use OBDB as a way of communicating across apps and across your people, if you just use it for that, then really what happens is that you can actually free yourself from the whole schema business, because that channel allows you to communicate whatever you would normally handle at a schema level. And in fact, it really means that this is what I'm doing in Minecraft, that you not only that you don't need a database, well, you got your database, the file system for storage, but otherwise, if you actually articulate a universal schema that you can pass around applications and users, then the app is really in charge of what it can do. And that's the
So Gary, I think what we're saying is like, yes, an ArbitDB doesn't work for us, so we're going to build a superset of that into WNFS directly. So it has not worked for those use cases.
Yeah,
there's some other pieces. So Brooke mentioned gossiping, and there's a few things like IPFS PubSub that we have turned on by default across all of our systems, but I don't think we like expose it directly, other than you can just call it directly in JS IPFS. So there's a bunch of other capabilities that are kind of out of scope of the database pieces. Helder's piping up and saying, you could store SQLite in WNFS. I'm like, yes.
Yeah.
So
yeah.
You can still mix and match all of these building blocks is the point.
Yeah, but all I'm saying that make sure that you play nicely with OBDB, because at the moment I have to load a separate one, IPFS, or at least make it possible to do that.
Okay, if you could write up any challenges you're having, that would be most useful, because we're happy to like do stuff so it doesn't, stomp on other things by default, basically.
Yeah. Okay.
Yeah. So I'll address your thing and then SQL right after. So in terms of real-time communication, that's on the roadmap, and that's a separate layer. So that's like a ephemeral session store that would look a lot more, I think, like what you're describing. Again, OrbitDB parts of it may be a fit, but that's a separate piece. That's like true real time or soft real time. This is more like, well, people are coming online and offline continually, and I need to pull large chunks of data to get a view of my database. Not necessarily real time yet, though should be extensible to that, but it's not really meant for like really quickly passing small bits of information back and forth.
It's just eventual, yeah.
Yeah. SQLite. So I posted this link to Actual Budgets, who I'm trying to chat with them as well, though I haven't yet. They're basically it's interesting, though. My understanding is it's a single user, i.e. a single human being. So they're not merging many sources. It's like one or two devices. And they're using CRDT to do row level updates and then exposing that with SQLite, which is kind of cool. So also an interesting direction to explore, though, then you run into all the schema stuff. So just, it's an interesting article. I'd recommend people read it.
So we did go over time, which is not uncommon for these things. But yeah, since we have gone an hour and a half, I think I want to reiterate, like, thank you guys for showing up. Like I said, at the demo day, we were pleasantly surprised by some of the interest and the early excitement. We're thrilled that this many people are willing to take an hour and a half on a Thursday and talk about this kind of stuff with us. I'm going to go ahead and stop the recording. And